Welcome to this exciting course on working with regular expressions for text processing. Regular expressions, often abbreviated as regex, are a powerful tool in text parsing. They allow us to match, search, and manipulate strings with precision and ease. This unit will introduce you to text parsers, tools that break down sentences or strings into their component parts. We'll explore their usefulness in different scenarios and demonstrate practical applications. Ready to delve into the world of text parsing and regex? Let's get started. Before we dive into the technical aspects of text parsing and make or programming, it's important to understand what parsing means in a more familiar context. Essentially, parsing involves taking a sentence or any structured text and breaking it down into its fundamental components. Think of it like dissecting a sentence to see how each word functions within it. Let's explore this with a simple sentence. I love learning about make. When we parse this sentence, we start by splitting it into individual words. I love learning about and make. Each word serves a specific purpose in the sentence structure. For instance, I is a pronoun and also functions as the subject. It tells us who the sentence is about. Next, we have love, which acts as a verb, expressing an emotion or action. Finally, make is the object, pointing to the topic, product, or concept being referred to. By breaking down sentences in this manner, we can better understand the roles and relationships between words. This foundational skill of parsing is essential, not just for language, but it also sets the stage for more complex parsing tasks in programming. Parsing is a powerful tool that helps us understand and organize information. Imagine breaking down a sentence into its core elements. By identifying each part, like pronouns or verbs, we can extract valuable insights. In a programming context, parsing helps analyze and deconstruct data based on structure, meaning, and components. Consider parsing customer reviews as an example. By examining multiple reviews, we can tally specific words or sentiments, such as counting how often words like love or hate appear. This provides a clear view of customer opinions. As a result, parsed data becomes comprehensible, enabling us to gain meaningful insights that inform decision making and strategy. Leveraging this technique allows us to transform raw data into actionable intelligence. Let's explore a simple yet powerful example of parsing in action using make. Imagine you've got a document filled with numerous email addresses. Your goal is to extract each email address individually. This is where text parsing comes in handy. By utilizing the text parser's match elements module, you can instruct make to search the document specifically for email addresses. Essentially, you're asking make to look for any text that matches the pattern of an email and pull it out for you. For instance, consider a line that reads, if you need to contact us, please email academydemo@make.com or helloacademy@make.com. The parser will accurately identify and extract each email, resulting in separate bundles containing Academy Demo at make.com and Hello Academy at make.com. This method of extracting specific elements is not only straightforward, but incredibly useful for organizing and handling data efficiently. Now, with a grasp on this basic concept, let's dive deeper into other scenarios where text parser modules could be beneficial. Welcome to a deeper dive into text parsing with Make. In this session, we'll explore how Make utilizes various text parser modules or transformers to convert and extract data in a way that best suits your needs. First, consider the Get Content from HTML Table module. This tool is fantastic for retrieving structured data from a web page. It scans HTML tables and returns a neat array composed of rows and columns, making it ideal for organizing tabular data. Next, the Get Elements from HTML module helps you isolate specific components from a web page, such as images or links. By pinpointing these elements, you can focus on exactly what you need from a large set of data. The HTML to text module serves a unique purpose by transforming HTML code into plain, formatted text. This is particularly useful when you want to store or present your data without the clutter of HTML tags. Lastly, the Match Elements module is your go-to tool for pattern-based searches. It scans string elements, identifying those that fit specific patterns you've predefined. This is especially effective for tasks like extracting dates or email addresses from unstructured text. With these modules, Make provides a versatile and efficient way to handle a wide range of data extraction tasks, streamlining your workflow and enhancing productivity. In Make, text parsing involves transforming data based on the module used. A popular example is extracting content from an HTML table. Imagine you have a table with columns like fruit and color, listing items such as apple and red and green. By using a text parser, you can convert this table into a structured format that the system can understand, which is typically an array. This array separates the headers like fruit and color from the data entries such as apple or red-green. This organization allows you to easily manipulate and utilize the parsed information based on your specific needs, creating more efficient workflows and data handling. The beauty of text parsing in Make is its versatility, enabling you to extract and transform data from various sources efficiently. Let's delve into how text parsing works in Make, specifically when dealing with HTML content. Imagine you have a web page filled with various elements and your task is to extract all the hyperlinks embedded within. Make's text parser modules can perform this efficiently by allowing you to target specific elements like links. For instance, consider an HTML page with numerous clickable links. Using a module designed to retrieve elements from HTML, you can specify what you're looking for, such as all the hyperlinks. The module will then process the page, pulling out each link for you. In practice, if you're parsing a page containing a link to the Make Academy, the module can output that link as a clear URL like https://academy.make.com/. This functionality not only saves time but also ensures accuracy, allowing you to effortlessly integrate this data into your workflows. Keep exploring different modules and see how they can extract precisely what you need from your HTML documents. When working with text parsing in Make, one powerful tool is the HTML to text transformer. This tool is designed to strip away HTML tags from your content, leaving you with just the plain text. Imagine you have a web page or a document filled with HTML formatting like bold or color-coded text. By using this transformer, it will simplify the content, removing all those tags and presenting the text in a clean, readable format. For example, if your HTML message says, "Hello there, friend, it's lovely to see you," where lovely is highlighted in red, the transformer extracts just the written words. "Hello there, friend, it's lovely to see you." This clean output allows you to use the text in various applications without worrying about unwanted formatting. It's particularly useful for tasks like data processing or text analysis, where only the message content is needed. With such tools, you can manage and utilize text more effectively for your specific needs. Welcome to our exploration of text parsing in Make. Let's dive into how different modules transform HTML content effectively. First, we have the ability to extract entire tables from HTML. This module scans through the table structure, giving you an organized array of rows and columns. It's perfect for when you need to work with structured data. Next, consider the module that finds specific elements within HTML, like images. If you're in need of retrieving certain components, this is your go-to option. Another useful tool is the HTML to text conversion. This takes the raw HTML and strips out the tags, leaving you with clean, formatted text ready for use in documents or further processing. Finally, we have the Match Elements feature, which leverages the power of regex. This is all about identifying standard patterns such as emails or links within your text. Don't worry if regex sounds complex. It's a powerful tool that we'll explore in more detail soon. These capabilities empower you to manipulate and transform data, enabling you to tailor it precisely to your needs. Welcome to the text parser examples section. Here, we're diving into practical scenarios where you can see how text parsers operate in real-world applications. Each scenario is designed to be straightforward, making it easy for you to experiment and learn as you go. First, we have the match elements example. This showcases how you can search through text to find specific patterns. It's a powerful tool when you need to pinpoint certain data like emails or URLs within a large text. Next, there's the get content from HTML table scenario. This is perfect for extracting data from structured tables in HTML files, allowing you to pull out only the information you need. Then there's the get elements from HTML example, demonstrating how to extract various elements embedded within HTML code, such as links or scripts for further processing. Lastly, we have the HTML to text example. This is useful when you need to convert HTML formatted content into plain text, which can simplify processing or analysis tasks. Each of these scenarios is a hands-on opportunity to refine your skills with text parsing modules. We encourage you to try them out and discover how text parsing can improve data management tasks in your projects. Enjoy exploring these examples and enhancing your understanding of text parsing. Let's explore how the Match Elements module can be used effectively. Imagine you have a block of text and need to extract specific information like email addresses. This is where the Match Elements module comes into play. It allows you to define patterns that identify and parse the pieces of text you're interested in. In our example, we'll focus on locating and parsing email addresses. Think of this module as a powerful tool that scans through the text and picks out elements that match your specified pattern. Although we'll eventually enhance this process with regular expressions, for now we're keeping it straightforward to ensure you grasp the foundational concept. By understanding how to set these patterns, you'll be better equipped to handle more complex scenarios in the future. So, let's dive in and get comfortable with the basics of matching elements. To start this exercise, imagine you're setting up a new scenario that simulates an email or website message. First, create a scenario named Make Advanced Course 4 Unit 1 to 1 inches. Then incorporate the Set Variable module to hold a piece of text. This step is crucial because it sets the stage for parsing specific data, like email addresses. Next, assign a name to the variable, in this case text with email, and paste the given text into the variable value field. This text includes a couple of email addresses. Once you've set this up, click Run Once. This action generates a bundle, essentially a packet of information that helps your system recognize and map the variable. The primary goal here is to extract or parse the email addresses from the provided text. This process demonstrates how the Match Elements module can be effectively used to identify patterns and extract specific data. It's a foundational technique you'll apply in various scenarios as you advance. To enhance your scenario, let's explore how the text parser module can be a powerful tool for matching patterns within text. This module gives you flexibility in extracting specific data, such as email addresses, documents, or even web content, by defining a pattern to search for. Start by adding the text parser and match elements module to your setup. This will allow you to zero in on the particular type of information you want to extract. By default, the option to continue the route even if no matches are found is set to no. This setting is beneficial because it can prevent unnecessary operations, which is cost efficient, especially when working with subsequent modules. Imagine you're tasked with retrieving email addresses from text. The pattern matching capability not only simplifies this process, but also ensures efficiency in data management. By consciously configuring these elements, you can streamline workflows and enhance productivity within your projects. In this example, we explore how to effectively use the text parser module in Make. A crucial feature here is the option to continue processing the workflow even if no matches are found. This can be particularly valuable when you want to ensure that operations proceed smoothly without interruptions. saving you operations if subsequent modules are connected. The pattern is your key tool for defining what you want to extract from the text. Think of it as setting specific criteria that the text should meet. For instance, today we're focusing on email addresses. By selecting the predefined pattern for email, you instruct the module to specifically identify email addresses within a given string. These predefined options are not only useful for this task, but will also play a significant role in later stages of the course. Remember, selecting the email pattern simplifies the process because it automates the identification of email formats without manually defining complex rules. This ensures accuracy and efficiency, especially when handling large amounts of data. Let's dive into how special characters interact with patterns in Make. When creating your matching pattern, you can enhance specificity by incorporating additional letters such as accented characters like or. Meanwhile, certain non-alphabetic symbols like hashtags or question marks are generally ignored in this context. This feature is particularly helpful when you're searching for elements embedded within a text that contains various special characters, including symbols or other non-alphanumeric markers. By paying attention to these details, you can fine-tune your pattern to only capture what you truly need. When you select email as your matching pattern, a new field for special characters will appear. For now, you can disregard this option and focus on mapping your text field with the email variable. Once you've done this, simply click OK, and don't forget to save your scenario to preserve your progress. Now that you've run your scenario, let's take a closer look at what's happening. Remember to bypass any warnings about transformers. They're not critical here. You're examining the output from the Match Elements module. Our initial input text included 2 email addresses. The module effectively identifies and extracts these addresses, parsing them into 2 distinct bundles. You can see how it separated academydemo at make.com and Hello Academy at make.com. This extraction process is powerful in automating data sorting, making further analysis or usage a breeze. Congratulations on parsing your first piece of text. You're doing great. Welcome. In this section, we'll explore how to extract data from HTML tables using the Get Content from HTML Table module. Imagine you have a web page or an email that contains vital information organized neatly in a table format. With this module, you can efficiently parse and retrieve data from these tables by targeting each row and column. Think of this as transforming static table data into actionable insights. Whether you're dealing with a list of contacts, sales figures, or product information, this approach empowers you to access and manipulate the data quickly. Through this scenario, you'll configure the module to recognize the table structure and extract the desired information, making it a powerful tool for data handling in your workflows. Let's dive in and see how it all fits together. To efficiently extract data from an HTML table, you start by creating a new scenario. Label it Make Advanced Course 4, Unit 1 to 2 inches to keep your projects organized. Next, include a Set Variable module from the Tools section. You'll want to name this variable Table. In the Variable Value field, paste the provided HTML text. This text represents a table containing information about different football players, their teams, and the countries they play in. Once that's done, click Run Once. This action will generate a data bundle, preparing the content for the next steps. By setting up your scenario in this way, you're enabling a structured approach to handle and parse complex data from HTML tables. When dealing with data inside an HTML table, it's crucial to understand the structure of the table in order to extract information efficiently. Although the module won't display a visual table, it will reveal the underlying HTML code, providing a clear view of how the table is constructed. By previewing this HTML, you can see how the table would look on an actual web page. Tables in HTML are organized with headers and data cells. Table headers are defined using the tag and contain the column's titles such as player, team, and league in our example. On the other hand, table data filled in by the tag contains the actual information associated with each header, like specific players' names, their teams, and the countries they are associated with. The goal here is to parse or systematically extract the information from these headers and data cells. This process allows you to manipulate the data for use in your scenarios without dealing with the entire HTML content. Now let's explore how to effectively extract and utilize this data in more detail. When working with data in HTML tables, it's often necessary to configure your parser to handle the information effectively. Starting with the text parser, it's helpful to ensure that the route continues even if no matches are found. This means your process won't stop unexpectedly due to missing data. Next, consider stripping HTML tags from the contents. Since the primary focus is the data itself, selecting the option to remove HTML tags clears any formatting, giving you cleaner data to work with. Now, regarding the decision to skip the first row, some HTML tables might not use the traditional table header tags and instead use standard data tags for their headers. By skipping the first row, you avoid treating these headers as regular data, which can simplify the parsing process. In setting up this module, the provided HTML should be formatted correctly, minimizing adjustments needed. Lastly, don't forget to map the table variable within the HTML section. Once that's done, you can proceed to save your scenario knowing it's set up to efficiently handle your table data. When working with HTML tables, you might find yourself needing to extract data organized in rows and columns for use in various scenarios. Running your scenario, you may see a prompt suggesting a transformer shouldn't be the last module. Just ignore this for now. Once your scenario is executed, check the output bundle. Here, the data from the set variable module will be neatly parsed into two separate arrays, headers and rows. The headers array contains the titles of each column, such as player, team, and league, while the rows array holds the corresponding data entries for each row beneath these headers. This breakdown helps in efficiently managing data, making it easy to manipulate or further parse for your application needs. Although this example focuses on parsing the first row, the same logic applies to the entire data set, enabling comprehensive data extraction and usage. Parsing data from HTML tables is a powerful tool in managing digital content. When you encounter a table on a web page, it consists of rows and columns that need to be extracted for further use. In our previous discussion, we saw how data from a table was split into arrays, one for headers and another for rows. This process equips you with structured information that can be easily manipulated or analyzed. Now that you've successfully parsed a table, you might wonder what else you can achieve with this data. The possibilities are extensive. You can transform this data, integrate it with other systems, or perform detailed analytics to gain insights. While we'll dive deeper into these applications later, take a moment to explore examples of how text parsing modules operate. These examples will show you the diverse ways parsing can be utilized to handle web page data more effectively. This foundational knowledge will be invaluable as you move forward. When working with HTML content, one of the key tasks is extracting specific elements that you might need for your work. This process is known as parsing. In this section, we'll explore how to identify and extract elements such as links, images, and iframes from HTML documents. Links are essential for navigating between web pages. Images can provide visual content, and iframes allow embedding of content from one site into another. The objective here is to use a scenario that retrieves these elements effectively. Imagine you have a web page or an email that you want to analyze. The goal is to parse it to identify all the links available, giving you a comprehensive list to work with. This is just one example of the types of information you can gather. As you continue, you'll apply similar techniques to other elements, enhancing your ability to manage and utilize HTML content efficiently. Now that you're ready to extract HTML elements, let's create a new scenario. Start by naming it Make Advanced Course 4 Unit 1 to 3 inches. This step is essential for organizing your work efficiently. You'll need to add a set variable module from the Tools section. This is crucial because it simulates environments like an email or a website. In the module, type HTML as the variable name. This lets the system know what type of data you're working with. Next, paste the provided HTML text into the variable value field. This text is formatted in HTML and will include several links. Doing this allows the HTML content to be ready for processing. Finally, click Run Once to generate a bundle. This process compiles everything so you can map the HTML variable for further use. Remember, each step builds on the previous one, so take your time to ensure accuracy. Now that we have set up our scenario, let's explore how to extract specific elements from HTML. Notice how HTML uses tags, such as the tag, to represent hyperlinks. This tag is essential for creating clickable links that take users to other web pages. In the HTML example provided, there are 3 different links we'll focus on extracting, one for the Make Academy, another for the Make Community, and a third for the Make blog. Each hyperlink is enclosed within the tag structure, allowing browsers to render them as active links. The href attribute is crucial. It holds the URL, directing you where the browser should take you when the link is clicked. Our goal is to retrieve these links through parsing the HTML data. By learning to extract these elements effectively, you'll be equipped to handle a wide array of tasks involving dynamic content on web pages. Let's dive into how you can accomplish this, ensuring the right information is gathered accurately from the HTML provided. Now that we're delving into extracting elements from HTML using the text parser, let's explore some key decisions you'll need to make. First, consider whether you want to continue executing your route if no matches are found. Setting this option to No will optimize performance by saving operations when the module doesn't find any elements, which can be especially helpful for large-scale data handling. Next, you'll choose the type of element you want to extract. There are 3 main options: images, links, and iframes. If you're looking to gather all image links, select the image option. Choose link if you need to collect all hyperlinks embedded on a page. The iframe option is useful for acquiring attributes of embedded sites, such as their web links or display dimensions. For this exercise, focus on selecting the link type to extract hyperlinks. Don't forget to map the HTML variable to ensure the module has the data it needs. Once you've configured these settings, save your scenario to capture your progress. Now that you've set up your scenario and run it successfully, let's explore the output you've generated from the HTML page. You'll notice 2 key components: inner content and attributes. The inner content refers to the visible text or label linked to the hyperlink. In this case, it might be something like Make Academy. This is what users usually see and click on when browsing a web page. On the other hand, attributes capture the actual URL or web address to which this label points. This is crucial because it enables you to extract and utilize hyperlinks from any given web page. By parsing these elements, you effectively gather both the text associated with hyperlinks and the URLs themselves, giving you powerful tools to organize or redirect data efficiently. Now take a look at your output bundle to see how this information is structured for you. Now that you've successfully extracted elements from HTML, let's explore how you can use this data. Imagine you want to organize these elements efficiently. You can map them to a spreadsheet, such as Google Sheets. This process is straightforward. You assign the inner content of the hyperlink to one column and its attributes, like the URL, to another. Essentially, you're creating a structured list of links that you can easily reference or share. This method not only keeps your data organized, but also allows for quick access and analysis. Congratulations on parsing your first set of hyperlinks. It's a fantastic step towards mastering data extraction. In this scenario, you'll explore how to convert HTML content into plain text, a useful skill when gathering information from web pages, documents, or emails. Imagine you have a blog filled with valuable content you'd like to use elsewhere. This process allows you to extract that information while stripping away any unnecessary code or formatting from the HTML. By using a text parser tool, you can effectively search through the HTML, identify the text elements you need, and remove any tags, leaving you with clean, usable text. This conversion is ideal for situations where you need to focus purely on the content without being distracted by HTML structure. Whether you're compiling data, creating summaries, or preparing reports, mastering this technique will streamline your workflow and enhance your productivity. Welcome to this practical example of converting HTML to plain text. In this scenario, you'll start by creating a new project, giving it the descriptive name, Make Advanced Course for Unit 1. 4. The aim here is to simulate content as you might find in an email or on a web page. Begin by adding the Tools module and setting a variable. This variable acts as a placeholder for the HTML content you're working with. Assign it the name text so that it can easily reference and manipulate any text embedded with HTML tags. Next, you'll paste your sample HTML code into the variable value field. This code snippet includes different types of headings and structured lists, which is typical of many web pages. The goal is to parse this content, stripping away any HTML to reveal pure text. Finally, click Run Once to process this setup, creating a bundle that allows you to work with your text in upcoming steps. This bundle becomes an actionable dataset, ready for further manipulation and learning exploration. In this segment, we're focusing on transforming content from HTML to plain text, which is a common requirement when dealing with web data. Our objective is to strip away the HTML tags such as headers and list markers, leaving us with clean, readable text. Imagine you have a website showcasing courses and workshops. The content is structured using HTML, utilizing various tags to define headings, lists, and list items. Here you'll see how to effectively convert this structured HTML content into plain text. This process involves removing all the tags enclosed within angle brackets, like H2 and Lee, while preserving the essential information within them. By doing this, you can extract meaningful content, allowing you to repurpose it for emails, reports, or any platform that requires unformatted text. Let's delve into how to achieve this seamless transformation. In this part of our HTML to text conversion process, we're diving into the text parser module. You'll be mapping the text variable you've set up earlier, keeping this step simple and straightforward. Notice the setting for line breaks. It's important to understand that a line break is what your computer generates when you press enter. This marks the end of a line in your document. Different operating systems like Windows or Mac handle these line breaks differently, but for this scenario, leaving it at the default is perfectly fine. Finally, consider the uppercase headings option. When enabled, any text found within HTML header tags will be converted to uppercase. This helps headers stand out in the text output, making it visually clearer and easier to navigate. Feel free to explore advanced settings, but for now, sticking to the basics is recommended. As we continue exploring how to convert HTML to text, let's focus on a helpful feature, the uppercasing headings. When converting HTML documents, you might encounter various header tags, such as OR. This tool allows you to automatically transform those headers into uppercase text. For instance, a header like "This is a header" will be converted to uppercase, making it stand out as "This is a header" in your final text document. This visual distinction can be particularly useful when you need to maintain clear organization and emphasis in your output. By converting headers in this way, you not only provide a cleaner layout, but also make your document more accessible, especially when it's processed by other applications or for printing purposes. To apply these changes, remember to confirm your settings by clicking OK and saving your scenario. This ensures that your configurations are correctly implemented in the conversion process. As we delve into the use case of converting HTML to text, let's explore what this transformation looks like. Imagine you have web content full of tags and formatting. When parsed into plain text, this content is simplified and structured for better readability. In our example, you see the transformed output from a collection of HTML content. The headers have been turned into uppercase, giving clear emphasis, while lists are neatly presented with bullet points. This makes it easier to digest complex information and access key points quickly. By removing HTML elements while maintaining the original content structure, the result is streamlined and efficient. This method isn't just about cleaning up code, it's about enhancing usability and accessibility for a broader audience. Try using this technique with an HTTP request to retrieve a web page. This practical approach will allow you to see firsthand how the transformation process can organize and clarify online data. Let's continue exploring more about how parsing can simplify and improve data presentation. Let's explore an exciting step in our journey with HTML tables. We're diving into a fascinating scenario called Match of the Make. Imagine you're managing data for a football website that organizes information about players, their teams, and the leagues they belong to. In this scenario, you'll learn to extract specific columns and rows from an HTML table, transforming them into a comprehensive text format. This will help in identifying key details such as which players are part of Italian teams. Rather than sourcing a table from the internet, you get to craft one using the Tools module. This custom table will feature three key columns: player, team, and league, filled with information from 6 different players. For example, envision entries like Antoine Griezmann for the player column. By practicing this, you become adept at parsing and manipulating data, enhancing your ability to manage complex data sets. This approach not only strengthens your skills in handling HTML content, but also paves the way for deeper data analysis capabilities. Let's dive in and see what insights we can uncover. Welcome to our exploration of text parsing within HTML tables. Let's delve deeper into how this works in the context of a football website that stores extensive data about players. Imagine you're dealing with a table from the site that lists footballers, the teams they play for, and their respective leagues. Our goal here is to efficiently extract this information. The text parser is a powerful tool that simplifies this process by pulling together headers and rows into structured data arrays. In our example, the headers, think of them as the column titles like player, team, and league, are bundled separately. Then each player's data fills in beneath those headings, forming a cohesive, logical structure. Through this scenario, we're specifically interested in players who are active in Italy. By focusing on this criterion, we can filter down the data, bringing key insights to light. With these abilities at your disposal, you're better equipped to handle large sets of data systematically, making the parsing process both efficient and straightforward. In this step, we introduce the use of an iterator. The iterator efficiently handles our data by breaking down each element into its own distinct bundle. This process is essential for organizing our data precisely, as it takes each row from the HTML table and divides it into individual pieces of information. For instance, each player's name, the club they play for, and the league they participate in are separated into different bundles. This means we can easily manage and manipulate each aspect separately. By converting every array item into its own bundle, we ensure that data can be processed meticulously. This method allows for more targeted operations, such as filtering or additional transformations, making it a powerful tool in our text parsing scenario. Welcome to our exploration of using HTML tables to organize and filter football data. Imagine a website that meticulously stores details about footballers, including the teams they play for and the countries they represent, all in structured HTML tables. Our task is to harness this data and identify players active in Italy. We start by extracting the relevant columns and rows, creating an organized array of football players and their associated information. The crucial step here is iteration. This process allows us to sift through the array, scrutinizing each element for key details, specifically the league or country associated with each player. Our goal is straightforward: pinpoint players who are part of Italy's football league. To accomplish this, we apply a filter. This tool scans the array of bundles created earlier, focusing on those that include Italy. Only bundles meeting this criteria make it through the filter, effectively highlighting our players of interest. As we proceed, think of this as a dynamic way to transform raw data into meaningful insights about football talent across different leagues, with a special focus on the Italian league. This method not only streamlines data retrieval, but also ensures precision in identifying key players. Let's dive into the match of the make scenario, where we use HTML tables to analyze football players' data. This example allows us to extract key details such as player names, their teams, and the countries they play in. The aim is to sift through this data and pinpoint the players currently active in Italy. To achieve this, the data is gathered into a structured text format. We then use an array iteration process, meticulously identifying those who match the specified criteria and play in Italy. This leads us to the final step, where the text aggregator module plays a crucial role. It compiles and displays our findings, highlighting players like Paolo Macchedini from AC Milan and Alessandro Make Piero from Make Ventus. This approach not only provides a clear overview of the player's distribution across countries, but also empowers us to leverage sophisticated tools for targeted data retrieval. Let's take a closer look at how this scenario unfolds and brings data to life. To get started with this use case, you'll want to build the foundational scenario for extracting information from an HTML table. If you've already created the Make Advanced Course for Unit 1 to 2 inches scenario, you can jump right in. If not, no worries. Let's walk through the initial setup steps. First, create a new scenario and name it Make Advanced Course for Unit 1 to 2 inches. This will act as your project workspace. Next, you need to define a variable called table using the set variable module. This variable will hold the HTML content you want to process. Simply paste the provided HTML text into the variable value field, then confirm with OK. Now add a text parser module to extract the data from the HTML table. You'll map the table variable to the HTML field within this module, which allows the parser to know exactly where to look. Keep all the default settings for now. Once everything is set up, run your scenario again to ensure everything is working as expected. And just like that, you are ready to move on. To continue building on your scenario, the next step involves adding an iterator. An iterator is essential for breaking down data into a manageable format. In this case, it will help you process each row of your table separately. Start by mapping the rows array. Once you've done that, run your scenario. You might encounter a warning saying, a transformer should not be the last module in the root. When this happens, simply click Run Anyway. This warning is just a reminder that ideally a transformer should be followed by another module to utilize the transformed data. After running the scenario, check out the output bundle. You'll see that each row from the table has been transformed into 6 separate bundles. This process will be highly beneficial as it prepares the data for more in-depth processing in the upcoming steps. To enhance your understanding of this use case, we are going to incorporate the text aggregator module into our workflow. This module is designed to compile a comprehensive report of Italian players from the data we've processed. By connecting it to the iterator, we're effectively setting up a pipeline where each player's details are collected into a succinct summary. The first step is to add the text aggregator to our iterator. This allows us to pull together all the necessary player information into a single, easy-to-read document. The importance of selecting the iterator from the source module dropdown cannot be overstated. This selection ensures that all data processed through the iterator is funneled into the text aggregator. It gives you one cohesive output, so you see a complete picture rather than bits and pieces. Think of it as consolidating all the answers from a survey into one report instead of sifting through individual responses. This approach not only saves time, but also ensures accuracy in the data you're reviewing. By doing this, you're transforming potentially complex data into an accessible format, making analysis easier, especially when dealing with multiple data points simultaneously. In this step, we're focusing on leveraging the text aggregator module to display the players' names and their teams. Here's how you can achieve that. Firstly, in the text field, you'll type name. This sets the format for what you want to display. Next, map the columns item from the iterator. The purpose is to pull specific data, in this case, the player's name and club, from an array. To do this, you'll rely on the bundle order position. This technique lets you select specific pieces of data based on their order. In essence, when you type the number 1 between the item and the bracket, you're instructing the system to look at the first position in your data set for the player as name. You'll repeat a similar process for displaying the player DOS club. Type club and set the bundle order position to 2. This retrieves the club name that's stored in the second position. In summary, this setup allows you to specify exactly which pieces of information you want to extract and display, ensuring that you have a clear, organized output for each player. Let's explore the first part of this use case by focusing on how we can adjust the display settings for aggregated text. This technique is essential when you want your data to be more readable, especially when dealing with lists or multiple entries. Start by enabling the advanced settings. This feature often reveals additional options that are quite useful for customization. Next, under the row separator option, choose New Row. This choice ensures that each piece of information is presented on its own line rather than being crammed into a single block of text. Once you've made these adjustments, remember to confirm your changes by clicking OK. Don't forget to save your scenario afterward. This step is crucial to ensure that your work is preserved and ready to use. By organizing text in this way, you enhance the clarity of your data presentation, making it easier to understand and interpret. To streamline your data processing, you'll need to add a filter between the iterator and the text aggregator module. Start by giving this filter a clear label. Here, we're using League Italy as an example. This makes it easier to identify its purpose at a glance. Next, you'll map the columns array from the iterator. Mapping involves specifying the data set that you want to apply your filter to. In this instance, we're focusing on a specific column of data. Now set the filter condition. Choose the .contains operator because we're looking to identify entries that include certain data. Specifically, type the word Italy as the target value. This step ensures your filter only processes data containing the word Italy, which could represent the country or league in a data set. After configuring your filter, remember to click OK to confirm the settings, and don't forget to save your scenario. This step locks in your changes and prepares the system for the next phase of data handling. By efficiently setting up this filter, you'll enhance the precision and relevance of your data outputs. Now it's time to bring everything together by running your scenario. As you execute the process, you might notice a prompt suggesting that a transformer shouldn't be the final module. You can safely ignore this prompt for now. Once the scenario runs, check the output from the text aggregator. You'll see it compiled into a single bundle, showcasing the names and clubs we previously discussed. This indicates that the filter and aggregation steps worked seamlessly to organize your data. With this final step, you've successfully concluded the scenario, and your setup is complete. Well done. As we wrap up this introductory unit on parsing, let's revisit some key insights. Parsing is all about dissecting structures into their component parts, whether in the context of language or data processing. In programming, parsing involves analyzing text, identifying its structure and breaking it into manageable segments. This process is essential for extracting meaningful information and converting it into a format that's usable in various scenarios. With Make, parsing becomes a powerful tool. You can extract data types that follow specific patterns, like an email address or key value pairs. You're also able to pull content from HTML tables, transforming it into data you can easily work with. Moreover, parsing allows you to retrieve specific HTML elements, such as lists of hyperlinks, and to convert HTML into plain text for further use. By understanding these parsing techniques, you unlock a variety of possibilities to leverage structured data effectively within your workflows. Congratulations on completing the first unit of this course. You've taken an important step in understanding the basics of text parsing. Parsing is essentially about breaking down text to make it manageable and functional, whether it's extracting emails, hyperlinks, or key value pairs from structured data like HTML tables. So, why is parsing useful? It allows you to sift through large amounts of information and pull out exactly what you need. This can be particularly helpful when you are automating tasks, collecting data, or reorganizing content for different uses. In your own scenarios, parsing helps transform raw data into valuable insights or actionable items. Whether you're building an app or managing databases, parsing can refine and optimize your workflow. As we move forward, prepare to harness the true power of parsing with regular expressions known as regex. This next step will enhance your capability to deal with complex data patterns efficiently. Let's keep building on this foundation. Great job so far.